All right, here's our lesson on graphing linear inequalities. Let's take as our first example 3x plus 2y greater than or equal to 6. Now what we're going to do here is we're going to first just treat it as an equation. This is called actually the boundary line. Boundary line is 3x plus 2y equals 6. So we pretend it's an equation and we graph that line. Now we already know how to graph lines here. I'll use the intercept method. The x-intercept, if I plug in a 0 for x and I solve for y, I would get what, 0, or I'm sorry, plug in a 0 for y. Guess I should write out the work here. Plug in 0 for y and I get 3x equals 6, x equals 2. Okay, so we got 2, 0 is the x-intercept. Let me graph that. Two, 0, x-intercept. Y-intercept, where you set x to 0. 3 times 0 plus 2y equals 6. Y is 3. So 0, 3 is the y-intercept. Let's plot that. There we go. Okay, now the boundary line is either going to be solid or dotted. Because I have this little half and equal sign right there, this means I'm going to have a solid boundary line, solid line. And let me draw my solid line. There we go. Here's my boundary line. Now the next step is to shade the solution region. One side is the solutions. One side contains all the solutions to the inequality, the other side does not. You have to figure out which side has the solutions. And so there's a couple ways to do it. Here's one way. We could actually test a point. Test any point you want that's not on the line. The easiest point is 0, 0 to test. I'm going to test 0, 0 and see if it works or not in the inequality. I'm going to plug it into the original inequality up here. 3 times 0, this is my x and y. 3 times 0 plus 2 times 0 greater than or equal to 6? Question mark. Is that going to be greater than or equal to 6? Well, no. No. 0, 0 is right here, and it does not work. It is not a solution, which tells me this side over here is not the solution side. I do not want to shade this side, so let me get rid of all those marks there. Okay. The solutions must be on the other side, and so this side contains the solutions. And I've graphed the solutions. What this means is if I pick any point, any ordered pair on the right upper side of this line, it will work for this inequality. Here's another one. Or actually, I should say, before we go to the next one, the other way to figure out which side to shade, instead of testing a point, you could just solve the equation for y. Let me take this equation here. Let me write it down here for you. 3x plus 2y greater than or equal to 6. Solve it for y. So 2y, move the 3x to the other side. Divide by 2. And solve for y, the inequality would look like that. When it is solved for y, this sign tells you which side to shade. Y greater than, shade above. If it was y less than, shade below. So since this says y greater than, I did shade above this line, and I have it correctly shaded. We'll try that with another one. Let's do this one. Let's take y equals, or not equals. What am I doing? Oops. Let's fix that. Y is less than 1/2 x plus 1. Okay. So first I treat it as an equation. This is my boundary line. Boundary line, I can't write. Y equals 1/2 x plus 1. 1, 2, 3, 4. The y-intercept is 0, 1. The slope tells me to go up 1 and over 2. Up 1 over 2. Up 1 over 2. Could go backwards here if I'm careful. And this line is going to be dotted, and because it's a strictly less than sign. So this means dotted line. If I had the little equal part like that under there, then it would be solid, but it doesn't. Get rid of that. So this is a dotted line, or I'll make it a dashed line, like that. And what that means is the points right on the line are not solutions in this case. If the line is solid, then the points on the line are solutions. Now I have to figure out which side to shade. Which side contains all the solutions? Well, since this is solved for y, it is very easy to tell. It says y is less than means shade below, and so I shade below this line. There it is. Any point I pick in this region will be a solution to the inequality. Let's try another. X minus 3y is less than 4. Okay, let's use intercepts again. The x-intercept, if this were an equation, would be at 4, 0. And the y-intercept, if I set x to 0 and solve for y, what we get? Negative 4/3, 0, negative 4/3. Okay. So those are my x and my y-intercepts. Let's see, 1, 2, 3, 4, 1, 2, 3, 4, 2, 3, 4, 1, 2, 3, 4. Solid or dotted line, this tells me that it is a dotted line or dashed line. So 4, 0. 0, negative 4/3 would be right around there. Dotted line, something like that. Let me fix that a little better. Yeah, good enough. Okay. Now I have to figure out which side to shade. Let me show you both ways. I could test a point such as 0, 0 here. Let me test 0, 0 and see if it works. Plug 0, 0 into the inequality. 0 minus 3 times 0. Is that going to be less than 4? The answer to that is yes, true. 0, 0 is right here and it works. It is a solution. That means that side contains the solutions, just like that. If you don't like testing a point, as I said, the other method is to solve the inequality for y, like this. I have to move the x to the other side, becomes negative 1x. Then I'd have to divide everything by negative 3. Now I just divided both sides by a negative number, so you must remember to reverse the inequality symbol like that. And we end up with y is greater than 1/3 x minus 4/3. Let me fix that. Whoops, didn't mean to do that. There we go. Okay, if you take a look, this is the line that we have, the dotted line, and right here it says y greater than, and so we were supposed to shade above the line, which is what we did. So there you have it. Okay, next. So what do we do if we have something like y greater than or equal to 1? Well, the boundary line is y equals 1. And we learned in a previous section that that's just a horizontal line that looks like this. Up here at 1, solid or dotted, this tells me it is a solid line. There. Now I have to know which side to shade. Well, it is solved for y. It says y greater than, so I shade above, and I'm done. There it is. I've graphed it. Graphed the inequality. What if I have something like x is less than 3? Well, we learned in a previous section that the boundary line x equals 3 is a vertical line, which would look like this at x equals 3. And this one is, because of that, is a dotted line. Now, which side do I shade? It tells us x is less than 3. So which side would have x values less than this 3? Well, this is x is 2 and 1. These are less than 3. And so I would shade the left side. And we have it graphed. One more example, and that is this one. (2x plus 4y greater than or equal to 5), and x is greater than or equal to 1. Now this is a compound inequality, and it's combined with an and. So if you recall, an and means you want the overlap. You want the region that is shaded twice, and that's actually what we're going to do here. Let's graph this one first right here. The x-intercept, if I set y to 0, would turn out to be 5 halves. So we've got 5 halves, comma 0, x-intercept. The y-intercept, by setting x to 0, will give us y equals 5/4. So 0, comma 5/4 is the y-intercept. So graphing this boundary line would look something like this. Five halves is 2 1/2, comma 0. 5/4 is about 1 1/4, about right there. Solid line looks like that. Now if I test a point, such as 0, 0, 2 times 0 plus 4 times 0, is that greater than, is that greater than or equal to 5? Is 0 greater than or equal to 5? No. 0, 0 doesn't work here, and so the solutions must be on the other side, so I shade above. Okay. So I've got that one graphed. Now I go to the next one here, this one. X greater than or equal to 1. Let's use green for that. The boundary line is x equals 1. That's a vertical line right here. It's going to be a solid line. And it says shade to the right because it says x greater than 1, which would be on this side. There. Now graph both of them at the same time. They are combined with an and symbol. An and means that we want the overlap, and the region which is shaded twice, or the overlap, is right there. And so this is our solution region for this compound inequality. Okay, that's it.